Hello, everybody, and welcome back. It is Jordan, psifertex, and
Gamozo.
we're here. Okay, so we have another round of LiveCTF. Neither one of us has been back today yet. This is our first stream of the day. I love that we've got a lot of new casters who've been joining us. We're preparing for a new round. They're doing the introduction kind of behind us. We've got we can see on their screens as we're looking at them. 4 teams ready for this match. We are going to be casting Macaroni. And do you say mhackeroni or macaroni?
I'm going to say macaroni.
Macaroni?
Just because I love it.
I think it sounds better.
Yeah.
I always thought it was mhackeroni, and then I finally heard somebody say macaroni.
Macaroni?
Like, oh, no.
Yeah.
That's way better. So macaroni and HypeBoy. We're gonna see on this stream. And then but we also have Maple Mallard Magistrates, the other name of PPP, and Straw Hat in the non-cast. We're not commentating on, but you can see their feeds as well in our alternate streams.
So who's been crushing it so far on the brackets?
I mean, in general, all of these teams are in the winners bracket. So every team we're casting right now has never lost. This is the undefeated bracket.
All right.
So this is a great one.
So we're going to see some very quick matches.
I think so. HypeBoy has just been destroying it so far. They may have sent up somebody different, though, because one thing that's different is this is the first challenge that we told them was not opponable. This one is actually more, we told them it was a crack me, so more reverse engineering crack me style challenge.
Oh, all right. So I might see some IDA today.
We'll see.
Wait, Binary Ninja, I'm sorry.
You know what? I wish that were true. However, we've actually only seen them. All right. Are we about ready for the countdown? So it looks like we're about ready to go live. So let's go ahead and let we're going to count it in. 5, 4, 3, 2, 1. Let's go. All right. So we're going to see both teams hop on in and get going. Who do you want to go with first?
This is really tough to say. No Binja that we can pick from? Because that would have been the first pick.
That would have been the obvious one. Let's go ahead and go to HypeBoy first, because HypeBoy has been just the fastest. The matches they've won have been incredibly fast so far. So I've been very impressed. Although, again, I don't know if they're going to send somebody different. If it's not the same person who's doing puntables.
Now, did you know that every single time I've cast this, it's gone to sudden death?
Oh no, are you cursed? Did you curse my challenge? So yeah, for full disclosure, this is my challenge. This is one of the ones that I wrote. And it's actually not something I normally would have done because I'm not a kind of an RE person necessarily.
Was that a drag and drop? What is
drag and drop?
Drag and drop into what is this application?
It's just VS Code. It's just VS Code with a terminal on the bottom.
Oh, okay.
So although I think I love the shell. So I'm guessing. Because it looked like this was a Mac, right? So it's a Mac that they've got a VM probably that they're actually running their VS Code in. Because I think so they've got their IDA. Oh, that was, did you notice that it was 7.7, I think, was the version of IDA?
Ooh, is that the most recent one that was leaked, or what?
No, I'm not going to accuse anyone of that. I'm just saying it's not the latest actual IDA. So, like, the analysis might be, oh, no, VoiceOver, did they hit too many accessibility keys too quickly?
Is that like sticky keys, but on Mac?
I think that's my guess. I think that's what they got.
Oh, I'm really excited to see a little crack me here.
All right, so they're dumping our source code out. That's a very different approach. Now let's go ahead and actually look over. On the other hand, at if I can hit the right one here, we've got Macaroni. On the other hand, still an IDA, right? So they're still just kind of statically analyzing.
Is that an SRAM 0? I don't think that's how you're supposed to seed your random number generator.
So I had a debate when I make this challenge of how hard I wanted to make it, and I originally had an SRAM time on it.
Yeah.
And then I thought, no, let's just make it a little bit easier. During play testing, it was like, look, we want this to be solved. So it's a very not random.
Interesting. I mean, it looks like there were 40 iterations of RAN. So at that point, the seed has been very randomized.
But you are going to get the same. You're going to get the same order with the same count of items here.
Yeah.
So yeah, they are going to get sort of a fixed order, but it's not like intuitively obvious from static analysis here.
This is interesting.
To figure out this order, you really want to like do that dynamically, or just kind of run it and either with a breakpoint like dump them out or. So actually over here on the other side, so HypeBoy, again, the first thing that they did, it's really interesting to me, they heard crack me, so they immediately just decompiled, dumped it to text, and now they're cleaning it up because they want to actually get this buildable. There we go. So you can see this is very clean. I love the way they're doing this. So all of the functions are very simple mathematical transformations, right? You can see it right there. They've got plus, minus, division, multiplication. And so they're pulling out the constant. So The plus and minus are just very large constants. The division is always a smaller number because otherwise you end up with just like zeroing out. You lose all the bits that were kind of there.
Now, did you make this manually or did you obfuscate it?
I had a generator, so it's pseudo manually generated. Like
okay.
The version that we're running is not like auto generated each time. There is one fixed copy.
Yeah.
That it worked on, and so okay. Oh, actually, hold on. Back on the other side. Do we miss it?
Simulation manager. What's that?
Yeah, I don't know, but I saw that. Okay, so again, there's a couple different ways you can solve this. You could throw it like into a solver, like a Z3. You could throw it into some sort of like, I'm here, go here, and like like one of the tools that like auto path finds might be able to actually like brute force your paths. So I'm really curious if we're going to see a mix of like. So they're looking for a are they going to drive it towards execution of the congratulations? And
yeah.
So. My solution, I just pulled out all the constants, put it all into Z3, and then, let it go.
Yeah.
But
do you think we're going to see Z3 here today or any sort of solver?
We haven't yet, so I'm curious. And we don't necessarily have to either. And some of these are trivially reversible transformations, right?
Right.
And so there's definitely going to be alternate approaches. I kind of would like to see a different one.
Yeah.
But certainly I know it's at least solvable with the Z3 approach.
So with SRAN, way back in the day, I'm pretty sure the entropy or like the state space of RAND was like 16 bits or 32 bits or something quite small. Is this a broodable problem?
So
is this a 2 to the 32 sort of thing?
It's not, and the reason why I think is because the thing that's being randomized is the order of the functions. So the functions each have all these different transformations.
I see.
So the only thing that's going to be random here is like we're going to call it function 10 first or 20. So that order is like sort of fixed random. It's not just obvious in the code what orders can be called because that has involved the random. But you could again. With GDB, you could nump that out. You could rewrite. Actually, you could recompile it.
Right.
The source decompiles cleanly. Pull it out, rerun it, and then print out the order before you run it.
And we got Z3 already over here on HypeBoy.
So we do have a Z3. So that's exactly. So and they've got it's the array here. Are we pulling out constants or I wonder what we're looking at in that array? So we've got the 8, 4. Okay, that actually the array is almost certainly going to be the order of the functions, right?
Right.
So they're saying that's the order of the functions called. And now they're gonna are they just gonna do this manually? It looks like at function
no
time, just go through each one of them.
No way.
Listen, the name of this challenge is actually John Henry.
Okay.
Okay, and this is sort of like the John Henry was the railroad man, like, hammering all day.
Yeah.
And like, is he going to beat the railroad machine or whatever?
Right.
So this is kind of, this is fantastic because I really thought, like, are people going to write some sort of like fully automated extraction, or are they just going to like copy paste values and pull it out?
This is terrifying to me because Z3 is, and Python in general, is not very generous if you make a mistake.
It's not.
If one of those slashes is not a 2/ and it's a 1/, you lost the whole thing, and it might take a long time to figure out where that very, very small error is.
Yeah, and spoiler alert, minor spoiler alert, I believe the second hint on this challenge tells them that like udiv is not the same as div. If you actually look at the division operations in Z3, there is a difference in signed and unsigned division.
Oh, and if you're looking through here, it would be very hard to catch the difference between a uint and an int when it comes to just popping through an IDA. Like right there, that's an int.
Well, and that may or not be right too, because again, the division operation that you're going to get, like it's implicit a lot of the time, and so yeah, it doesn't stand out at all.
Oh, that's really tricky.
So it wasn't an intentional part of it. But it very well could be, and we did know that might bite people, which is why I said that is the second hint that's queued up.
Yeah.
Specifically says like, go look at these things, because that's the operation that's gonna. And then what we'll see is if they try to do this in Z3 without the correct division, it'll just churn away, unable to satisfy, right? And so it just kind of like times out, which is frustrating.
But honestly convenient. It's better than. I mean, getting that timeout is like,
false answer.
Seeing unsat is like, okay, I know that something is wrong. I have to do something.
Yeah. Well, it can also, the other failure case, sometimes it can just like churn and just sit and spin, and you don't know if you did it wrong. Hopefully they realize, again, this is a speed competition. I didn't give them something that would take 10 minutes to run a Z3. That's not the design. So if you hit that, something has gone wrong. So hopefully they'll be like, the nice thing is once they get it, they can run it, and then if it go off and do other things.
That's one of the really interesting parts about a CTF and using a solver is like if I'm working on something in the wild and I'm bringing in a solver, I don't really know if it's satisfiable or not.
Yeah.
And in a CTF, you know it's going to be satisfiable.
It's going to be solvable, or maybe the Z3 is the wrong tool, but like you know there is a solution. And again, particular challenges, these LiveCTF challenges are meant to be fast. They're meant to be really
right.
So we want to showcase the sort of traditional, basic, like archetypal like, challenges.
So what would your threshold be when you get approached with a challenge like this and you see that there's like a switch statement with a bunch of different functions? When would you go immediately to automation or some regex or something to process this versus this very manual approach, which honestly I think is very clean if all the functions are tiny and it's only 20. But if you get surprised and you get to a later function and it's big, you might really regret it.
Yeah, 40 of these functions was meant to do. I did it by hand certainly, but I also had the lack of pressure and stress when I was writing my solution that wasn't timed. I designed it so that I thought it would be faster, although again, I'm a Binja dev, so of course in Binja it was like 4 lines of Python to dump out each function and each operation.
Oh, you wrote a script for it.
So I wrote a script that actually dynamically like pulled out all those contents.
Have we seen anyone write a script for IDA or Binja or Ghidra?
No, I don't think we've seen so far anyways, although I haven't caught all of the matches. I've been doing some other things around it, but so far, and I think that's just because most of the people are focusing on the fast. Actually, let's go back to HypeBoy.
Yeah, for sure. It looks like they already have the code extracted in the way that they want.
Yes. So
now
they pulled out those because again, remember they just dumped the text from IDA and then copied and pasted, which I think is definitely a faster approach.
Yeah, I definitely think HypeBoy is ahead at this point, and I like seeing that mhackeroni made a transition into using lambdas. They were doing like def, making the full functions, and then they're like lambda, 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 lambda.
Yep.
So now it looks like we have very similar things on both sides, except mhackeroni is still manually extracting those, and it looks like HypeBoy's already kind of approaching the problem here.
Yeah, so they've got the big vector. They know the size of that. They have created this value at the end where they know that there's this final check. It must be equal to this value. So it's definitely on track. The question is going to be, again, on their division. So you notice they're actually doing just a single division here on their operations, and this really is going to need to be the UDiv in Z3 if you're going to use Z3 on this, which again both are so far. We're seeing.
Is there a way that you can set that on the variable and say just make everything unsigned or something on this variable, where you could just do a one pass, change all of them?
Well, I would probably honestly do it with a text replacement at this point, like multi-cursor or something. And that's, which is an interesting note that's basically the fact that they did a text replacement. They took it out of IDA, deleted a bunch of lines, and then manually did multi-cursor to replace it. I think that's a sort of in between, like a full-fledged, I've written a script to fully automate it, or I'm doing it line at a time by copying and pasting the way we're seeing with mhackeroni.
Now, are they going to have to go in reverse
rand? Oh, there we go. We just saw the double division.
Oh, there it is.
So they did just, it's closer. It's now the same spot mhackeroni is, but there's still neither one is going to get the right answer until they can realize that that's not quite the same division. So I was afraid this is going to be a sticking point for teams, which again, worst case, they're going to get that hint. They will get that after 35 minutes into this round.
Right.
They're going to get notice of that. So.
That's really tricky. So.
Oh no! Wait a minute. This is interesting. So it looks like they're commenting out the actual Z3 components now. And what are they?
Are we trying to brute force?
That's a good question. Brute forcing a 64-bit value is going to be
impossible.
A little tricky, yeah. I don't think they have the compute
especially
for that.
in Python. I don't even think a 32-bit is going to be possible with arrays and stuff in Python, especially with like dynamic dispatch of functions.
So the arrays, the array lookup for your functions, the function order. Yeah. What you really should do at that point is just put them all into the same function, not call them as functions, and do them straight through.
Yeah.
That would be if you really wanted to brute force it. So let's see, though.
Do you know if there are many solutions? Like, are there many?
There are multiple solutions.
Because you say it's 64-bit, but what's the actual space?
I don't know. Actually, that's a great point.
Like, what if there's a very convenient one, very shallow?
It's possible. And when I simply did was when I tested it, I got a single solution. I tested that it worked, and then I went and then tried a few other ones. I would specify not that, just to get a few more. So I knew. So I know there's more than one, but I never actually characterized and tried to.
That would be really fun.
So it is possible that there's maybe a lot of this and actually just I don't think there are. I think, in fact, earlier versions there were. So again, remember I mentioned that I tweaked those constants? So that like the plus and minus are just large random constants, and then there's a much smaller on the division. Because if you have a very, very large division, you'll end up with like 0 or 1.
Right, exactly.
And then everything on throughout it, you've sort of lost all those bits in there. So by having the smaller less than a byte-sized division. I think you're keeping most of the bits of entropy up in there, and so or at least most of the bits are kind of floating.
I think it really depends at what ends at the end of that expression and where everything wraps up. So if someone was watching from home right now and was interested in tackling this problem, is there a way for them to get those challenges?
Not yet.
Not yet.
We
Okay.
will be publishing, so at the end of the competition, assuming we're still awake and
Okay.
coherent, we have a GitHub. We'll be putting all of the challenges.
Perfect.
We have thought about trying to do it kind of live so people can play along as soon as the round
Right.
ends. But even throughout, it wouldn't be a huge deal because the teams could certainly like remotely connect to another team's box and pull the binaries off. It's not like it's a secret.
Yeah.
Once the binary is out, the binary is out. So
Exactly, yeah.
Yeah, that would be fun for us. Okay, here we go. Crypto.util.number.
Interesting.
I'm very curious about this alternate approach that we're seeing.
So I haven't had much time to look at the IDA disassembly. What does the random factor in? I guess since it's seeded with the same thing, you always get the same ordering of the functions.
Exactly.
So what is the controlled value? Like the scanf that prompted for that LLU.
You were asked to put the very first value in that is multiplied or add, like that goes through all these transformations.
I see. Okay.
So you give it that single 64-bit value.
Okay.
And then it's going to call function 8, function 4, whatever the order of the function is. So that random is just a very slight off. And again, this is one of those things where the challenge could have been easier or harder based on how we tuned that. But we could have, for example, like made every 5 minutes a different random order.
Yes.
And so you have to get your solution under that time, and that would sort of hint that you knew it would be solvable in less than that.
Huh. This is going to be really interesting.
So switching back over, it looks like where are we at on Macaroni? We've got their
We got
mixture.
Python errors right now.
Oh no, yeah, I have seen a couple
which is
of.
not a good sign. What is this? Unsupported operand type for bitvec ref and int. Oh, you're going to need to convert those raw constants, aren't you? No, you shouldn't have to if you. There's like two different bit vector things in Z3, and I think one of them you can just do straight up like Python things, and one you can't. I never remember which is which.
The other one is again that what happened
Whoa.
here? Oh yeah. So again, we're trying to do kind of text replacement.
Oh, now we're back to sign division.
We're back to single. Well, not even. We're back to floating point division in Python, which is just not even close to right.
Is that allowed on bitvex at all? Do you get an error when you do that?
They're going to get that error. Yeah.
Okay.
Exactly. That's exactly what they're going to run.
Oh, it's solving.
Is it? Did they actually get that?
It said it's solving.
I don't. It does say solve. Okay. Oh, again. So. If it's working, again, I don't think they're going to get the right answer. I think it's going to run. I think they're going to run in that situation where it's just going to like spin forever because they don't have the right division. I could be wrong.
Well,
I'm not an expert
with that SRAM, the functions aren't running 0 through 20 in order, are they?
No, they're not. They're not.
And it looks like this is kind of assuming that
they
are?
Well, so they have the R at the beginning.
Oh, did they run through and get the values?
We'll have to keep an eye out on whether they – oh, here we go. Hold on. What are they – oh, they just changed – oh, so I think they're inverting. Yeah, so now they're just trying to invert all the operations. And this is something that I didn't actually try, but it might be a valid solution. You may very well literally just be able to, like, invert all the operations. Although you'll notice they didn't change the order. So if you're dividing one way, do you multiply? I have to think in my head, like, does it? Maybe it doesn't matter? Or, like, I forget
don't know if it works directly like that, but I'm also not some math genius.
Oh, I did just see Macaroni do a really smart thing. Oh, and actually, we just saw the same thing from HypeBoy.
Checking
they just checked the
checking
scoreboard
for hints.
because the hints do come in at 20 minutes, and I think we're not quite there yet, but maybe close.
Very close, yeah.
So that was really smart. You can tell, I think in the beginning rounds, teams were still figuring that out.
Yeah.
It is cool to see that they're remembering that. So and again, if we talk about like the hints, the first hint I don't think will tell them anything. It's just kind of more of a generic use the solver, something like that. I forget the exact details of the hint, but that second hint is going to be the one that gives them like, hey, division's important. Look at UDiv.
Right.
Because again, I think that's gonna be something that's gonna block them. So
yeah,
that would give them like 15 more minutes to solve that before we run into a
yeah. Now
situation.
It looks like we're doing some Vim regex replacement here to, I guess, do some sort of transform on the code. But this is kind of scary. I wonder if there is a saved copy of the original form of these operators, because if there isn't, are you just relying on your undo buffer? And
I hope
what if you lose those? Because Macaroni did all of these manually. So if they lose this, that's another 10 minutes of data entry, basically.
And I think they open themselves up to just copy pasta errors or to typos way more.
That's
than
very
what we
dangerous,
saw
especially
with
like when you're copying from IDA. You have like the C syntax where you have the ULL and stuff. So you have to like make sure you're not copying the U, and it's very easy to grab the U, double backspace, remove one digit, and then you're just toast.
So let's see. We're looking into.
Wow.
Okay, so now they're just taking in
putting
each of the functions.
Oh, are they going to transform it so they get the order and they just have everything in order? Because it looks like they're going to try and do some sort of a transform on the code itself. Right. Which is Okay. They're trying to use Python to do the regex.
And now you got two problems, right?
Yeah.
As the joke goes,
yeah.
when you use a regex, now you have two problems if you think your problem is solved with a regex expression. So they're changing.
This is really scary.
Yeah.
Like when I see this, I see very high chance of risk. Ooh.
That's not what they wanted.
I don't think that's what they want at all.
Minus plus.
Divide. I mean.
Oh wait, hold on. Are they doing in a single character array? No, that's just.
This is an interesting approach.
I'm not sure what's going on with that. All right,
I'm not sure either.
Let's go ahead and take a look back at not us. Let's go ahead and take a look back at HypeBoy rather.
All right.
Oh, we're in it. Okay, in it debugger. Interesting. So, like I said, I kind of expected. I wondered if people were going to pull the debugger to get the array order out. But
is this 64-bit? Yeah.
It is.
Okay. 64-bit x86.
Yep. Exactly.
Oh, we're looking at this straight assembly, which is always a sign that maybe you're not confident in the information that you're getting directly from the decompiler.
Well, and again, that's actually really wise on that division in particular, because that might be a way that it jogs your memory, and you don't just think about the abstraction level at the C layer, but you start thinking about what's actually happening. So, okay, so where are they breakpointing? They're breakpointing on.
Yeah, this is really interesting. I'm kind of surprised no one has a symbolic engine that allows them to just run this very simple main function and just get the symbolic expression.
I wondered about that. We did think somebody could just autopone this with the right
I think it'd be like a 1-minute solve, because I didn't see any modulo operators, so it should be quite easy.
Exactly.
And yeah, that's kind of interesting. Do you know how long it takes for Z3 to solve this when you have the right expression?
So at least on my hardware, it took I think less than a minute. I think in fact at one point I had made it up to 50 functions, and it was starting to take 3 or 4 minutes to solve, and so I intentionally dropped it back down to 40 because I wanted it to be less than a minute. I wanted it to be fairly clear, that you were. I didn't want people guessing is it taking too long because I've done something wrong or because so the correct solution should take about a minute to run, which I think is.
Did you symbolically simplify the expression, or mathematically simplify it?
No. I literally just copied and pasted, put them all as constraints, and let it go.
Yeah. Yep. Okay. So there's a chance that someone could probably get it even faster if they reduce, because right now they're doing this whole lambda function thing, which will be a pretty bloated expression, and I'm sure it reduces down.
Oh yeah.
But that's always a tough thing in Z3. Is it faster to do a simplification pass, or I've had it where doing a couple functions, simplifying, adding a couple more functions, simplifying has been faster than putting the whole thing in. But I've also had the opposite.
Yeah.
I'm sure if you've worked a lot more with it, you kind of have a good feel for which way to do that.
Ironically, yeah. So for me, this was actually one of the very first. I've done a couple other challenges involving Z3 over the years, but actually, partly I wrote this as an excuse to explore this more and to try it out and to do, and also because as I said earlier, the goal of a lot of these LiveCTF challenges are what's the core element behind some of these common challenges that we run into.
Yeah.
And so I thought a basic crack me where you use Z3, you pull out some formula and you run it through. And again, knowing that okay, with these transformations, there's probably other approaches, which I think they've both abandoned Z3. It seems to me that neither one is really using a Z3. Yeah. So we're not seeing Z3 at all.
Yeah.
They're really actually just trying to do the bit shifting and inversion, which quite possibly work. I don't.
You haven't tried it.
I haven't tried it, so it might run. It might not. There may be other reasons why it wouldn't.
That could be quite difficult. I think it really depends on how these operators overflow and everything. I don't necessarily
know
sure
that you model
these are
things
reversible.
the same way.
Yes.
Exactly.
Yeah.
So I am going to be very curious.
What do we have over here? Why do we have multiple things on HypeBoy?
So base is not invertible for the given modulus. So whatever inversion function they're trying to do.
Wow.
That's an interesting. So I've never actually seen that. Apparently, the crypto library has an inversion where you can say just invert this math operation.
Yeah.
Or no. Is that bit inversion? I'm not sure what that inverse function is actually.
Right.
I'll definitely be looking that one up.
I see the shift and mask. It looks like it's trying to make sure that those are 64-bit values, but shouldn't BitVec handle that for you?
Again, they're not using BitVecs at all, right? They've switched over to a pure basic math, which again, might be possible. I just don't know.
If I were to ever approach a bit problem, I would never use Python for it when it comes to this.
It's not well suited.
Right.
It really isn't. Yeah.
But it's hard to switch over. So.
Yes, and it's really fascinating to me too that both of them started with a solver. Both of them just decided to bail on it when they're like, wait a minute, the solver is not the right approach. But it still could be.
Yeah.
Like, again, it is absolutely
So they're
going to
get that hint at 35 minutes to use
they
a
will
solver.
they're going to get the hints that's going to tell them to particularly use Z3's UDIV. In fact, actually, I'm going to go put the mic down and I'm going to go ask what the hint is because I don't remember what it was.
All right.
I'll come back and I'll let everybody know.
Sounds good. Yeah. All right. Yeah. HypeBoy's really got kind of all of this weird bit operation going on. They're trying to mask everything down to get to that, 64-bit bitwise operations, which in the big space of Python, it's kind of hard to get that. Did you get our info?
I did indeed confirm. Okay,
all
so
right.
it was as I thought. It specifically says use Z3 UDIV. So it's pretty clear that, and then we'll see. But again, they might not be wrong. I'm not willing to say this isn't solvable this way. I just feel like there's a lot of easy ways to mess it up and to try to get your exact.
Yeah, it's interesting.
What was that over there? We've got on Macaroni.
Yeah, we have the list of all the functions. We apply they're applying the transform onto those functions to, I guess, order them in the right way.
But we have two F13s. I just noticed. I don't know what they were duplicated it. Oh, 14. Were they?
Oh,
did they have it off by one again?
Oh no.
The copy pasta risk is real.
Yeah, because X over 49
So
hex.
they did a little vim macro to increase the digit. Is that Control A or something? I forget the exact. There's a key to literally increase the number that I'm currently selected. Is a hotkey in vim.
Yeah.
And then they macroed that. So again.
And then they're gonna go manually fix up this, and that's. Was that 13 or 14? This is really scary.
Okay, but they're back to BitVec. So we are seeing.
And they added F40 to it. So it really comes down to if they have these expressions right, and I don't think they do with the single div.
Yeah, that's what they're going to run to. But the good news is then if they do get that hint and kind of come back to that, they might be better prepared for it than the approach we're seeing from
I think that
HypeBoy.
The timing of when that hint comes in could be a really, really big deciding factor, and it's like any minute now.
The first hint's gone out, but again, the first hint wasn't super useful. I didn't
was it 20 minutes and 35 minutes?
20 minutes and 35 minutes.
Okay.
So we've still got another maybe 10 minutes, I think, before, give or take, before the next hint goes out. This was about 5 minutes ago that we saw the first hint go. So they could definitely do it. And I am glad that in our playtesting, like I said, this division bit us as well. So we at least knew that was going to be a gotcha.
I know where Macaroni is in their headspace right now. I see exactly what's going on. They're looking at around this F13 through 15. They're looking at IDA. They are concerned that they have something wrong, and it's just.
Hey, they're going to use dog bolts.
Yeah.
So they want a second opinion too.
Right. This is terrifying. It's basically like, is it time to just give up and just basically try from scratch with a new approach? Or do you go and you try and manually verify that you have the right implementations of these operations? And I don't know. That's really, really, really tough.
Especially in a speed competition, right? Where literally every second kind of counts and you're just nervous that
Are we going to see a script by any chance? Oh, a database snapshot. Nice.
Okay. So they're
Decompiler
it's just
Explorer.
dogbolt.org. It's all you got to do. I stole that name from somebody else on Twitter when we created this. So this is actually a joint project from a couple of folks. So Ilfat from Hexrays and Vector35, makers of Binary Ninja. We both pay for the hosting, and Vector35, we wrote most of the actual interface. Some of the Anger folks have some code that are part of it too.
OpenAI?
Oh,
Did I see a Chat GPT?
They almost did it quickly, like they were embarrassed though to show it.
Can you rewrite those functions?
Okay, so they're going to use this as a smarter text replacement, maybe? I'm curious. I am kind of excited.
Now, would you trust the result of ChatGPT to the level of a solver being able to reason about it?
I think if all they're going to ask it to do is to do a bunch of formatting and to paste in a bunch of output, I feel like that's a fair thing. Oh, fun note, by the way, the Binary Ninja that's running a Dogbolt is not the latest dev version. And so it actually, I think on these operations it's all fine, but for some of the
and Anger and Ghidra are still...
They'll get there. They'll come through.
How big would you say this binary was?
Oh, it's not very large. I could pull it up separately, but it's not super big. In fact, usually IDA comes back faster on Decompiler Explorer. In this particular one,
Let's see. No way. That looks very good.
Pure text processing, again.
It's
not terrible.
Very good. No way.
Yeah, but like, I think it's good for that. So that's pretty good.
I didn't really see anything that looked off in there.
But the problem is you don't know.
Yeah.
And you can't. Oh, did they have to teach about division?
Oh no.
Oh no.
Oh no. Oh no.
Everyone's like
macaroni.
Poking around the same thing.
And they have F40, which shouldn't be in there.
It's not. There is no F40. Yeah. So there are only 40 total functions, starting at function 0 to function 39.
Now, are they going to go and just change it to a double div?
What's the order, though? Hold on. Oh, no. Okay, no. They are.
They're doing the transform.
They do look up their array list. So, yeah.
I think the way they do this is pretty good.
That part's fine. Right. Absolutely.
Do you think if they had the double div operator, this is just already basically solved?
No. Because, again, the double div is still signed, I think.
Can you write the inverse of those functions?
I don't. Yeah. See, now it's like at a certain point you're going a step too far, and
right.
ChatGPT is going to start hallucinating on you. I don't know if this is it or not. Oh, until you notice their solver just said something about was sat in the background. So that actually I'm a big fan of. If they're running a different copy of the script with the solver while they go off and try to do the version, that's good
Two
for
different
them.
approaches at the same time.
Brilliant.
That's a good way to go.
Great use of time.
Hard to keep both that in your head, but
yes, and make sure you don't invert the one thing from the other.
Are those the inverse? Or did it just do like a dumb inversion where it did a negation or something?
And what are they gonna? We're gonna escaping. Oh, they're doing all. So here's their division. They're gonna get rid of the division again. But again, that's not quite what they want. But they're gonna be well situated when that thing comes through.
Yeah, and HypeBoy just checked on that hint.
And just as a so they're still looking for the hint. They know it's not too far out, but we do have a few more minutes. Let's actually go ahead and follow up what HypeBoy's been doing and catch up with them, because I don't think they're still no Z3. All their Z3 solver stuff is still coming out, so they're still leaning into that inversion approach of really just trying to invert the operations to see if they can get that value.
And I guess the goal is to just run through and just run it through backwards.
Yeah, you'll just get a constant out. If you could perfectly model the inverse of those operations, that would happen. It's just tricky to do, and there's a lot of ways to get that wrong. So we'll see. And with the Z3, there's basically only one way to get it wrong, and it's literally just the division. It's just the division that makes it tricky.
I see the double division went back in over on Macaroni.
So did they get an unsat? So we've got sat assertion error. Okay, so they know that it was unsat. And then they're changing it again with the double division. So again, I'm actually.
Did they miss a 0 when they copied that?
Was it on which side of it? Was it?
Is that highlighted all the way to the other 0 on Macaroni?
00LL. Also, let's see. Where is their final comparison? So the order of the arrays.
Unlocking in 227 seconds.
Oh, I didn't even notice that before. It does give them the. They know. That's great. That's great. It does let them know. Oh, that's right. I think I saw Glenn.
They do have the right value. Okay.
So the value is correct. 100 at the end.
Interesting. They really need those double divisions.
When I wrote this, I literally just had a debug version of it. I put in the input value I wanted to be the answer, and then I just checked the value at the end, then I hard-coded it back in and recompiled it, right?
Yeah.
So it's really easy to find the solution you want. Now, I did still have to write the Z-theory. I did still have to prove it was solvable, and that's also how I could find there were multiple solutions. But it's kind of easy on a forward operation. Okay, hold on. What are we doing here? Out equals
Zmod.
Zmod. Oh, no. Yeah. Okay. So they're essentially doing now what we saw before of they're trying to constrain. They're going to use Sage math.
Really?
So are they going to do the sort of inversion approach that we've seen HypeBoy trying, but they're going to use Sage to try to do these inversions and try to model the way that the opcodes are going to behave, but invert them. Yeah. So I was a little skeptical of some of these inversion attempts, but I actually really like. That
inverse of that doesn't exist.
I really like the HypeBoy approach here, where they're still got their solvers kind of running. So run the solver, but then let it go and see if you get an answer while you go off and try other things.
Was that HypeBoy or Macaroni?
I'm sorry, thank you. That was
Macaroni.
Macaroni. I
Okay,
misspoke
yeah.
on that. Yeah. HypeBoy still seems that we can double check on them over there.
They have a whole
no,
new Python
back to
script?
Z3. They're back to Z3. Hold on, did they?
Yeah.
Okay, they didn't see the hint yet though.
So how do you do the unsigned divide in Z3?
It's just a function called udiv. It's literally a built-in operation called udiv, which is why we tell them the exact function name in that hint.
Right.
Because I think that will be that's the last stumbling block that either one can do. The other thing is I'm keeping an eye on our alerts. I don't think I've seen the other. So remember, as a reminder to our viewers, you can go over to the other streams and you can watch the 2 other players that have been doing this. So we've got Maple Mallards and Straw Hat. And I haven't seen
they're still working away.
I think they're still working away as well. So my bet is I really wasn't trying to troll everyone.
It's kind of interesting. Like I've used Z3 for one time, and it was for a Maple Story hacking thing. It's a long story.
It's a long Maple story, maybe. Hey,
gosh,
sorry, I'm a dad. I can do that jokes.
So, and I've already had it drilled into me to make sure that I'm doing the right div operator.
Yeah.
And I've used it once, so you would think that people who have done this a lot would probably immediately be going to that. Now, maybe it's because they saw int64 and IDA or something, and they're just taking that.
Immediately jump from there. Yeah, that's entirely possible.
Yeah, that's really tricky. Is it all of the functions are unsigned, or is it just like one of them is unsigned? Because if you did that, that's just rude.
So the values themselves are all unsigned values, and in source you don't differentiate. You just div, multiply, whatever, and it just happens to be if you have unsigned values, it's gonna be an unsigned div.
I see.
But again, in decompilation, you just see division, multiplication, addition, subtraction. Which is, like...
Does Binja differentiate those?
Binja does actually show you in high-level IL, right? So, like, in...
It does, like, U/ or whatever?
It can do U, yeah. So Binja will actually tell you if it knows the operation signedness of either a comparison or whatever it is, which is not valid C. It's one of our arguments about, like, why ILs are better than just, like, pseudo-C or a C output. Because you can actually do hinting as to what type of thing it is.
To me, that's mandatory. Like, whenever I have printed out any of my ILs, it's always on all of the operations that are signed or unsigned.
Yeah.
It is explicit,
you
S
should
or
absolutely,
U.
Like, do it.
It's just so important.
Right.
It's the difference of, like, having an ODE and not.
Or in this case, spending an extra 15, 20 minutes getting your solver to work. Okay, actually, let's go back. We've got, I'm seeing on HypeBoy, we now, is that it? They've got a V4. Hold on. They're running it. They've got a value. Okay, yeah, they've got a value. They're running it. Oh, no. Now, let's see. Are they checking the input? Does it check?
Are they doing the inversion thing?
Well, they're putting it. What format is the input? Is it hexadecimal or is it?
It was LLU, so it should be an unsigned 64-bit int. That actually tricked someone up yesterday for about 20 or 25 minutes.
Oh, no.
One of the teams, I think, didn't know that it was hex.
Yeah. So I don't see. They haven't checked the. Okay, so they're having copy paste errors. Try again. Okay, now are they going to check that scanf? Please go check. Yes. No. Go check the scanf. Go look for that input.
It was LLU. I do remember that.
Okay, so
that was like the very first thing that I picked out.
You did notice this one was LLU. I should remember, but I wrote this 2 weeks ago, so like I don't even remember my own.
Yeah, that was like the first thing.
I switched it back and forth. A couple times I was doing hexadecimal. A couple times I was doing doing integer values.
ZPi namespace. Okay, so they should have.
Oh, fantastic. Okay, so I just got
was that a love letter?
It was. They're telling me how much. No, they're telling me that Straw Hat won. So Straw Hat has beaten Maple Mallards in our uncasted one. So if you were watching that stream and you've joined us now, you may have already seen the end of it.
Wow.
Straw Hat won their version, and they again got a different number than the expected solution. But I'm not at all surprised.
Z3 UDiv. He finally
the
popped it up.
Is out. Oh, and UDiv is not defined. We are seeing it on both of them.
Yep.
We're seeing. Okay, so both have the hints.
Yeah.
This should be
honestly.
So at this point, it's a race to see who can fix their implementation.
I'm putting my money on Macaroni because if they go back to ChatGPT to do that transform to do the UDivs, they're going to get the result very fast.
Though. Watch, they're just doing a Vim macro, and they're doing it, and they're almost done.
It's kind of interesting that
we've got it. Oh, here it is. HypeBoy though is coming through.
Oh.
They've got a value. It's shown as correct.
And now they just have to.
Oh, they're going to get a submission. Submitter 12?
Yep.
They've got it. I think they've got it. Here it is. And that's going to be... That is it.
Congratulations.
Nice. Oh, no, and we just had one so close.
Oh.
Macaroni was just behind it. That hint was exactly all they needed. That was so close.
Wow.
We thought that might do it. Sure enough.
It was kind of crazy that Macaroni did the manual copy pasting from IDA initially, but also used the most automated ChatGPT approach. So it's just two complete
ends of the spectrum.
Yeah.
We saw both. But that was and it was exactly the hint.
It was the UDIV.
They just needed the UDIV. They both got it within just seconds of each other.
Wow.
It is interesting though to note that I think as we saw, Straw Hat actually won theirs before I think that hit may have come out. That hit like just came out.
Yeah.
They all fixed it and were able to solve it. But I'm going to go back and watch the VOD now and see what Straw Hat did.
Right.
Because I think their solution may not have even been exactly the same. So
honestly, I think in my head, one of the approaches that maybe would have come up to me is just randomly try both signed and unsigned. Like make a generic function.
Right.
Because how many divs were there? 5?
Yeah.
What is that? 2 to the 5 different combos and just try all possible combos.
And you know it's at least the same one for each of your divisions, right? So you don't have to like do it. You can just do it 5 times essentially. It makes it a lot easier. So that was fantastic. All right, well, I'm excited because we haven't had to use another sudden death, which is always good news. We had a good round. Everyone, we've got two victors. Congratulations to HypeBoy and to Straw Hat for their wins. But honestly, Mhackeroni and PPP that lost, they're playing into the lower bracket now. They can still be back in the finals
for sure
as well.
Yeah,
so.
Absolutely. Now, I don't want to put you on the spot, but who do we have coming up next?
Let me pull up that. I've got the chart right here. So actually, I think we could. Well, I won't do the bracket on stream. Next up, we're gonna do a couple more from the lower bracket, actually.
Okay.
So I think we're gonna pull in. The next 2 are gonna be actually the 2 from this that lost are gonna be right back around. So they're gonna be coming in for Mhackeroni versus Shellfish.
Okay.
And Maple Mallor versus Norse Code. So
all right.
Again, even those the sort of lower bracket matches are gonna be fierce and great competitors.
Perfect. Sounds good.
Awesome. Look forward to it. Thanks everybody for joining us. We'll see you just in about 15 minutes as we reset, get the new teams in here, and we'll be back.
Cheers.
Take care.